Well, we're still talking about equations of linear functions, and we looked at scatter plots. We used Excel spreadsheet to help us do this. And now we're in this chapter section where we're looking at regression and median fit lines, and we're going to be using our calculator, our TI-84 calculator, to create a scatter plot and then find a regression line that gives us an equation for the linear function. So here we've got instructions. Now this is example 1, which starts over here on page 255 but goes over to page 256. And here we're asked to write an equation of the best fit line for the data in each table. We got 2 of them we're going to look at. Name the correlation coefficient. Now the correlation coefficient is a number that the calculator will compute that tells us if our correlation is positive or negative, and the closer we are to 1 or -1, then the better line of fit that we actually have based on the data that we have input. And so let's see, writing an equation of the best fit line for the data in each table, name the correlation coefficient, round it to the nearest 10,000th. Let X be the number of years since 2003. Now that's going to be important as far as how we input our data. And so here we got a hockey team. We got some data on that. And the table shows the number of goals of the leading scorers for the Mustang hockey team for each year from 2003 to 2010. Now since it says let X be the years since 2003, when I input this data in a moment, instead of 2003, I'm going to enter 0. Instead of 2004, I'm going to enter 1, and so on and so forth. And then I'm going to enter my goals. So I'm going to hop over here to the next slide, bring up a TI-84 calculator, and we are going to do a scatter plot. And then from the scatter plot, we're going to do a regression line that will give us both the correlation coefficient and the equation for the line. All right, we're using our TI-84 calculator to do scatter plots and lines of fit. And so let's see, to start off, there's a couple of little housekeeping things I want to do. I'm going to go in here to y equal, and okay, I got an equation in there. So I want to clear it. So I'm going to hit clear. And then I want to turn my stat plot on. So I'm going to hit second y equals, which is stat plot. Make sure it's on. Right now it's off. So I'm going to hit enter. And you can see that it's blinking there on. So I'm going to hit on. And I'm looking at the different types of graphs that were put together. And this option that's highlighted is the one I want, which is a scatter plot. All right, now I'm going to go in here to stat. And I'm going to get my list, and I'm going to choose edit. And let's see, I got L1 and L2. L1 is like my X values. And if you recall, we're doing for years since 2003 out to 2010. And actually what I've already got in L1 is going to work. I'm not going to have to edit it, because 0 would be 2003, 1 would be 2004, 2 would be 2005, 3 would be 2006, 4 would be 2007, 5 would be 2008, 6 would be 2009, and 7 would be 2010. So that's good. But I do have to change my L2, or my number of goals scored for the leading scorer for the Mustang girls hockey team. I highlighted L2 here. I moved the cursor up. I'm going to hit clear and then bring it down. And now I can enter this data. Let's see, we got 30, and now we've got 23, and 41, and let's see, 35, 31, 43, just entering the data that I'm given, 33, and 45. Okay, let's see. Before I look at this graph, I want to look at my Windows settings. So I'm going in here to window and X minimum 0 to 10. Well, I had data from 0 to 7, so I'm okay with that. I'm going to leave that alone. And then on my Y minimum and maximum, which is my number of goals, let's see, we went from like 23 up to a high of 45. I think I'll set this Y minimum at 10 and the Y maximum at 5. That should, 50. That should include all the data that I entered. And let's go look at the graph and see what we look like. Okay, so there's a scatter plot of this data that we entered. We can see it here. It's got a little bit of an upward trend, but positive correlation, but it is scattered out a bit. Now, to get us the best line of fit using the TI-84, I'm going back to Stat, and now I'm going to move this cursor over to Calc. And if you look, I got several choices. In fact, it goes even beyond the screen. But this option 4, linear regression, AX plus B. Think about that, AX plus B. That looks like slope-intercept. Linear equation. So I'm going to choose option 4. And it's going to bring me to this screen. And all I'm going to do is enter my way through here. And it is going to give me an equation and a correlation coefficient. Now, the correlation coefficient is represented by R. In this case, R equals 0.6142. We're asked to round it to the nearest 10,000, so 0.6142. That's not actually too good. That's not actually very close to 1, but it is what we have for this data. If it was really close, if it was a really tight best line of fit, we'd be closer to the number 1 than what we are. And then up here, let's see, there's the equation, y equals ax plus b, and I could substitute in for a, 1.87, let's round that to the nearest 10th, 1.87x plus, substituting in for b, 28.58. And so I could write this equation as y equals 1.87x plus 28.58, and I've got a correlation coefficient of 0.6142. Now, we're not asked to do this in this section, but I am going to show you how we can put this equation without having to memorize all these numbers in TI-84. I can get it to load it in there for me. So I'm going to go into y equals, and before I enter anything, I'm going to hit vars. This button here, vars, and I'm going to choose option 5, statistics. Then I'm going to move the cursor over to equation, and this option 1 is a regression equation. That's what I'm trying to do. So I'm going to hit enter, and it loads that equation in for me. Now I'm going to go back into my graph and let's see what happens. There, it's taking that regression equation, that best line of fit that we calculated, and it's inserting it into my graph. All right, well, there we go. Using a TI-84 calculator to create a scatter plot and using the TI-84 again to give us a best line of fit, and then we graphed it. All right, so we're learning about how to use our TI-84 to create a scatter plot, and then move forward to getting a regression line or a best fit line along with the correlation coefficient. Now we got a little bit of a different data set. We're asked to do the same thing, write an equation for the best fit line for the data in each table, name the correlation coefficient, round to the nearest 10,000th, let x be the number of years since 2003, and again, that's important as to how we're going to input our data into our list. Rather than 2003, I'm going to use 0 because 2004 is 1 year since 2003, and on forward actually till we get out here to year 7. So let's go in and let's create another scatter plot. All right, so we're going to create a scatter plot. First thing I'm going to do is I'm going to go into y equal. I'm going to clear whatever data I have here. Then I'm going to hit second y equal, make sure my scatter plot is turned on. Here it is turned on because I used it before, and it's showing me here in the blue what type of plot I'm going to do, which is a scatter plot. I'm satisfied with that. So now I'm going to enter my data, and I'm going in here to stat. I'm going to choose edit, and I got L1 and L2. Now, we just did a scatter plot using L1. And so this is my years since 2003. So I don't have to do anything with that to edit that data. That goes from 0 to 7. But my L2 is going to change. So I'm going to go up here and I'm going to go highlight L2. I'm going to hit clear. And then I'm going to arrow down and that'll clear all my data in L2. Let's see, we're going to enter this date. I got 63. Enter. And then I've got 44. And enter. And then I've got 55 and enter. And 63 and enter. 81, enter. 85, enter. 93, enter. And lastly 84 and enter. So now I'm going to go back in here to Stat. I'm going to Calc. I'm choosing option 4, linear regression, AX plus B. So I'm going to choose option 4. And then I'm simply going to enter through here until it actually calculates. All right, so here we go. So now my correlation coefficient, where it's R equals 0.8495, that's to the nearest 10,000th. That's a little bit better than what we had before. And then my equation would be, substitute in this 5.95 for A, and substitute in this 50.17, let's say, 0.17 for B. And so my equation would be 50.95x plus 50.16b, and that would be my equation with a correlation coefficient of 0.8495. And again, I want to go over here and I'm going to put this in my y equals, because I want to just take a look at the line. This is not something we're actually asked to do in this example, but it's a good idea to learn how. I'm going to hit y equals, then I'm going to hit vars, and then I'm going to choose 5 for statistics. I'm going to move the cursor over to EQ. I'm going to choose this option 1, regression analysis. It loads in that equation into y equals, and then I'm going to hit the graph, and it's going to put the line. Oh, I need to change my window settings. Let's see, 0 to 10, and X is still good. Let's see, my Y minimum, I'm going to set my Y minimum at, I think I'll set it at 20, going to 100. See if this won't help us out a little bit. There you go, that's better. Now I can see the plot of my data, and it's putting the line of fit for the data that we have of the number of goals scored by the team for each season. Scatter plots using a TI-84 calculator and lines of fit.